Hello and welcome to this lecture where you are going to continue understanding multi-layer neural networks. The focus will be on calculating the error. We need to compare the predictions of the neural network with the expected outputs from the dataset. As you can read here in the title, the error is also called as loss function. When working with neural networks, it is very common to hear about this term. We are going to use the simplest algorithm that we have used for the single-layer perceptron, which is the expected outputs minus the prediction. Although this equation is quite simple, it is adequate to solve the XOR problem. Later in this course, there is a lecture that shows other ways to calculate the error, which are more suitable for more complex problems. In the first column of this table, you can see x1, in the second x2. These are the inputs. The class is in the third column, or the expected outputs of the XOR operator. In the next column is the prediction, and just a reminder that we did the calculations to obtain these values in the last lecture. For example, this is the prediction for the first instance, for the second instance, for the third instance, and for the fourth instance. It is the application of the sigmoid activation function. Finally, in the last column, you can see the error value, which is the subtraction of the two columns. Each of these rows indicate an instance of the dataset. Let's now analyze the error calculation. 0 minus 0.406 equals minus 0.406. 1 minus 0.432 equals 0.568. 1 minus 0.437 equals 0.563. Finally, 0 minus 0.458 equals minus 0.458. In this example, we are considering whether the number is positive or negative. However, we can get the absolute number to have only the difference between them, without considering if it is positive or negative. To know the average of the errors, we can add all of them without considering if it is positive or negative, and then divide by 4, which is the number of rows. The average of the error is 0.49. The goal is to reduce the error, and we obtained these predictions using the random weights that were initialized. What we need to do now is to adjust the weights to try to reduce the error to the lowest possible value. If the error decreases, we can conclude that the difference between the expected outputs and the predictions is smaller. For example, for the first instance, the expected output is 0, and let's suppose that the prediction was 0.01. Or for the second instance, the expected output is 1, and let's suppose that the prediction was 0.9. These example values will be close to the expected outputs, so it means that the neural network is learning. In short, when we manage to approximate those values, it is an indication that the neural network is managing to learn and find correlations between the inputs and the outputs. In the next lecture, you are going to learn the algorithm to update the weights. See you there!